Bridges allows us to reach our workplaces, services, school, to transport goods to their various sell points or to make the most out of our free time. Here, we can see a typical view of road network in a large city. We can see how many bridges are located within this network and how vital they are to the city life. This picture describes a typical case in most of the developed countries. Looking at the road sign here, we can understand why bridges are the most critical components of the road infrastructure. Although some of them looks very funny, like the weak bridge or the narrow bridge or low bridge ahead, we understand the impact that they all have on the road network. In some area where road maintenance do not exist and the bridge maintenance is not a common thing, traveling over a bridge can become a challenging task. Bridge management is a task of great responsibility. Most of the public is not aware of the hard and complex work needed for keeping the bridges in a safe condition, assuring a high level of service. But when something gets wrong, it is always on the front pages. So if we're talking about bridge management, what are the challenges? The first challenge is the large number of bridges and road structure. For example, we can see here the large number of highway bridges around Atlanta, Georgia. We can see that some of them are marked with red color, meaning deficient or in bad condition. The second challenge is the aging structure. We know that many of the developed countries had a golden age of bridge construction in the 60s and 70s of the 20th century, about 50 years ago. Taking into account that until that beginning of the 90s, the bridge maintenance program were very limited or even do not exist, we face today with the results. A new challenge is related to the new structure and the new bridges that are constructed those days. In many cases, these projects are located in a very dense road network. This creates great new challenges for the road authority on how to maintain this structure with a limited access or a minimum disturbance to the road user. For example, we can see here the interchange with the bridge that is marked in blue and think how we are going to maintain this bridge or to inspect it. When we look at the bridge network, we face a data management challenge, as some of the bridges has a great number of documents and inspection records data while others do not have any. As a result of that, we need to be able to efficiently manage bridge database, and on the other hand, we need to find efficient ways to close the gap of those structures that do not have any historical records. We have constant need for detailed, updated data throughout the bridge lifetime. New data should be comparable with old one. In most cases, it is not easy to retrieve relevant data for specific bridge elements and investigate its condition over a period of time. This is done using tabulated reports and various sketches of drawing prepared by the designer or inspectors through the time. Next challenge is the accessibility problem. We always have impact on the road user. This becomes more and more complex as on one side, the traffic demands are higher and the road network becomes more dense, while on the other hand, our bridges degrade in time. Even if we use the most advanced approachability tools, we still create an impact on the road user and the traffic delays. Our challenge here is to maximize availability of the bridge to the public while still maintaining our bridges. So we can say that we constantly need to minimize costs and to maximize the level of services. If we look at this partial list of bridge management challenges, we should ask ourselves how can we improve the process. Let's look at the simplified bridge management process. The very basic part here is the theoretical background, helping us to define our methodology. As bridge owner, we all need a professional methodology for managing our bridges. What we also need are professional bridge engineers and bridge inspectors. We need to train these professionals to know our methodology and to act accordingly. To date, bridge inspections are the main source of data needed for higher professional management processes and decision making. The heart of the bridge management process is the BMS. You can see here in the center of this chart. We use different types of bridge management system. Some can be very sophisticated, others are simple. Some manipulate the data in a complex way, while others keep it simple. But all of these systems are using the data that comes from bridge inspections, also from bridge testing like NDT, and to some extent bridge monitoring. So we can describe the process in a simple chart like that. Or we can also detail it in much more complex way. But what we can also say is that bridge management is a complex process. Different countries and organizations have different methodologies. Different levels of data mostly depend on inventory size, organization type, and country regulations. Some countries have very large bridge inventory that makes it harder to manage each bridge in a very detailed way. Others, like concessionaires or city, have a smaller number of bridges and can allow a much detailed process to be done. Almost all BMS exists today are tabular based and are hard to manage. Most of them present a similar architectural framework. Some have better bridge visualization and some are only tabulated. For example, you can see here a three typical screen from a different BMSs. This BMS come from Canada and this one from Israel and that one come from New York City. We can see that they are all based on tables and only some of them have graphics. Let's look again at the bridge management simplified chart and let's focus on the bridge inspection part. Let's try and identify the weaknesses of the present practice. On the inspection level, we can identify few. For example, we use full manual inspection work. This process requires extensive time for data collection. If we multiply that time by the number of bridges in service, we get enormous investment. Although we use trained bridge professionals for the inspection process, it is still highly subjective. In order to retrieve previous inspection data and to prepare our work, we have to invest a lot of time and need to download high volume of data trying to find a relevant item for a specific element or a bridge segment from the past. We still have extensive use of non-digital forms with a very limited sketchability, except for hand sketching. A lot of efforts are still invested in trying to improve this part. Let's try and look again on the simplified bridge management process and identify some other weaknesses of the present practice, mainly looking at the BMS processing itself. On the management level, we can identify others. All data is managed through a database table without a real structured visualization. This makes it hard to most of the users. We can always see that BMS managers do it very efficient. However, when we come down to others end user, we see that they are struggling a lot with the most of the system. If we want to create a complete view of a whole bridge performance, and we have a quick understanding for the reason for its performance score, we have to drill down into details and causes. This is not easy process and involving paging in many tables and documents in order to understand the causes. We also have complicated data stream from the site to the processing and decision-making stages. And at the end, most of the data is non-transferable from one BMS system to other. So what are the problems that CBridge seeks to solve? Using CBridge suggests processes, we try to improve the inspection process, make it more efficient with a better quality data. We try to reduce the subjective processes to minimum by using defect recognition process. We also try to connect inspection data directly to Bridge B model and reduce data loss to minimum. We try to reduce the gap between the quality of data available in the BMS and the information needed for reliable decision-making and subsequent design and construction work, mainly by doing the following: enabling 3D BIM bridge data management through bridge life, make all data comparable throughout time, what we call 4D. This means that we can load all data gathered for a specific element in a specific bridge and present it in a visual way on the bridge model. This can help comparing the changes and understand the deterioration processes for the specific element in time. We want to enable bridge experts to view results in a fast and reliable manner and use it for design. We do not want the expert to go over and over to the bridge site seeking for complementary information for the design. We want to use the visual data gathered from the inspection for the next stage of designing the treatments. We also like to enable data export with unified processes using BIM formats.